Alright, so as I was saying, these two graphs, even though they look kind of different in the middle, as you move farther and farther out, they look almost identical. If you were to even zoom out farther, you would see that the graphs look almost exactly the same. Alright, so this is how we write that. Alright, as you can see, I'm attempting to use the end behavior model, f of x over g of x, for these two functions. If I can show that when it goes to positive and negative infinity, this goes to 1, I'm good. So, if I divide these two functions, I can simplify it like this. Basically, I just split up the fraction into different terms. And then the next step, if we simplify each of the fractions individually, this is what we get. Now, of course, 1 just stays as 1. These, as x gets really large, as it approaches infinity, each of these are going to go to 0. So this limit equals 1. And if the limit as it approaches infinity and negative infinity both equal 1, then the end behavior model, basically the end behavior of these two functions, are like exactly the same. Okay? Alright, why don't you guys go ahead and pause the video here, try this one, and then when you think you have the answer, just hit play. Alright, this is the answer you guys should have gotten. The end behavior model is just the first term here. And if you graph it on your calculator, you'll find that there are no horizontal asymptotes. Alright, let's go on to this one. Find an end behavior model for this function here. Alright, basically for end behavior, we're just going to be looking at the front terms. So I've got 2x to the 5th over 3x squared, which simplifies to 2x cubed over 3. Or you could write it like this. That is the end behavior model. This one, once again, we're going to be looking at the front terms. We've got 2x cubed over 5x cubed, which simplifies to 2 over 5. Alright, pause the video here and go ahead and try this one over here. Alright, this is the answer you guys should have gotten. 4x cubed over x simplifies to 4x squared. This is the graph of the function. As you can see, there are no horizontal asymptotes. Okay, so I'll write that here. Alright, let's go on to the next example. Okay, let f of x equal x plus e to the negative x show that g of x equals x is a right end behavior model, while h of x equals e to the negative x is a left end behavior model. Okay, so for the right end behavior model, we're going to be taking the limit as x approaches infinity. Okay, so this is what we have. I'm going to split the fraction up, just like so. X over x is just 1. This one, if you were to graph this, you would see the limit as x approaches infinity is 0. Okay? Now, because the limit as x approaches infinity equals 1, this is, in fact, a right end behavior model. Alright, now for the left end behavior model, we will have to find the limit as x approaches negative infinity. Oops, negative infinity. And in this case, we're using f of x and h of x instead of g of x. So here we have x minus e to the negative x over e to the negative x. Alright, and once again, I can split this fraction up. Alright, so I split this fraction up also. If I pull up my calculator, this is actually the graph of x over e to the negative x. And as you can see, as x approaches negative infinity, it is approaching 0. 0 plus 1 equals 1. So this is, in fact, a left end behavior model for f. Alright, go ahead and pause the video. Try this one over here. Alright, this is the answer you should have gotten. This problem is nice enough. They didn't tell you to show anything or to prove anything. They just said to find a simple basic function. This is the right end behavior model. This is the left end behavior model. Alright. This one, we're really just going to be graphing it. Let me pull up my calculator. Alright, let's see here. Sine of 1 over x graph. Okay, the limit as x is approaching infinity. As you can see, let me zoom in a little bit. Yep. Actually, let's just change the window. There we go. As you can tell, it's getting closer and closer and closer to 0. Okay? So that's the answer for this one. If you want, you can draw a little sketch of the graph. I'll pull up the graph one. There it is. But you don't have to. Alright, go ahead and pause the video and try this one. Alright, this is the answer you guys should have gotten. The limit as x approaches infinity, so it just keeps going up and up and up, so it goes to infinity. The limit as x approaches negative infinity, it goes to 0. Alright? And that's all the notes for today. I hope you guys have a good day.